Hello, students. Welcome back. So, in this session, I'm going to be talking about mean median mode. And this session is a little bit more theoretical in nature. Okay, so when is mean useful? Somebody had asked me this question, and the answer is this. Number one, for understanding the central tendency of your data. So, for example, let's say you have customers, these are your ages, and you want to know that what is the typical age of your customers. So the mean tells you the typical age of your customer. That's what you mean by when you say understanding the central tendency of your data. Also, when you are trying to perform feature engineering and pre-processing, so most of the time your learning algorithm, they require or they assume that your features are centered around zero, and most of the time they are not. So you actually perform standardization, and basically one of them is z-score normalizations. For that, what you do, you subtract. Okay, you subtract the mean and divide by the standard deviation. So for that you need mean. Even for handling missing data, sometimes you have data and you have some values that are missing. So what you do is you impute your missing values. Okay, your missing values are imputed using the mean of your feature. Okay, for comparing groups. So basically, let's say you are working in a sales department and you perform some marketing campaign. So you calculate, you compute your mean sales before and after your marketing campaign, and you try to see if your sales went up or your average sales went up or your average sales went down before the marketing campaign. So this is basically comparing groups. Also, for performance metrics in machine learning, so some evaluation metrics, they are based on the means. So you actually check whether your machine learning algorithm, are they doing good or bad based on the mean. Okay, so one of them is like mean squared error in regression. Another one is aggregating data right here. So when you are performing your EDA or exploratory data on analysis, often you compute mean across various categories, across various classes. So for example, you want to calculate the mean salary for each job role. Maybe it could be IT job role, it could be HR, it could be customer service, it could be any one of these in a company. So you compare the mean salary for each one of these job roles. Maybe you want to identify trends. So what you do, you can actually you do something called moving average in time series. So by looking at the moving average and time series, it kind of helps determine or detect patterns in your stock prices, or even, like, for example, let's say COVID-19 cases. Okay, now, when is mean not idle? Well, when your data is skewed. In other words, for example, your income and housing prices, you're going to come across people, their income is like very, very high, okay, which is not your normal. Because most of the people, they make an income would fall in a certain range, but sometimes you come across these CEOs, the top manager, which are very few values, and their income would be very high. Housing prices, same thing with housing prices. Your data is very skewed. Another instance where mean is not very idle or may not be very good idea to use would be in the case of outliers. Another one would be when your data is ordinal or categorical in nature. Okay, when you're dealing with category. All right. So why is median useful? Unlike the mean, your median is not affected by outlier values. Okay, your outlier values would not affect your median. I'll show you an example in a minute. What do I mean by that? Also, they give you a better sense of typical value, especially for skewed distribution. And it is best when your data is skewed or contain outlier. That's when you want to use your median. So when is median preferred over mean? When you're dealing with income or salary data, for example. Why is that? Why do we actually prefer median over mean when you're dealing with the income? Well, the reason is a very few high salaries, okay, CEO founders, they can drastically pull your mean upward, making it misleading. So, for example, let's say this is your salary right here, okay, salary right here, 30,000, 33,000, 35,000, 40,000, and 5 million right here. So there's one guy, he's making 5 million, but look at them. Most of your salaries are between 30, 32, 35, 40. So this one guy who's making 5 million, he can make your mean almost like 1 million, okay, which is not really accurate. This is misleading. But your median is going to be 35,000. So 35,000 is more realistic number for typical worker. So in this case, you want to deal with median. You want to work with medians, and that's why, by the way, that's why the government and organization, they often report median household income instead of mean household income. Another example would be real estate prices. By the way, we're dealing with when is median preferred over mean. So another case where median is preferred over mean is in a real estate prices, housing market. So why is that? Because few luxury houses, they're worth millions, can skew the mean. So if you look at the housing prices, most of your housing prices, they'll be like, let's say 100,000, 120,000, 150, 180K. And then all of a sudden you see this one price, which is 5 million. So in this case, if you calculate your mean, it will be approximately, let's say 1.1 million. This is misleading for most buyers because most buyers are in the range of 100, 120, 150K. So your median, on the other hand, if you calculate median over here, the answer would be 150K, which is a typical house price. So median in this case would be a good measure. And that's why, by the way, real estate reports, they usually report median house price. Same thing with your medical data. Again, medical data, they tend to be skewed, some of them. So for example, let's say you're trying to calculate recovery time, hospital stay duration, or waiting time. So your data can be skewed. So for example, let's say hospital stays days. One person stayed for 2 days, another three, four, 3, 4, 5, and then one guy stayed for 60 days. So this is very rare. And because of this guy who stayed for 60 days, your mean value would be 12.8 days. It is inflated by by one guy who stayed for a very long period of time. On the other hand, your median is 3.5 days, which is a better summary of your typical patient. So that's why, by the way, medical researchers often report your median survival rate instead of mean survival rate. Now, here are the three strong examples where mode is most useful. When you're trying to find common category, customer preference, all right? So let's see if you're trying to find oh, hold on. What happened to my mouse? Oh, there you go. So if you're trying to find the most common category or or customer preference, in that case, your mode is useful. So, for example, a clothing store wants to know the most popular shirt size. Well, let's say your data is medium, large, okay, medium, large, small, medium, large. In this case, your most common value, which is your mode, is M. Okay, so most customers prefer medium size. All right, why is it useful? Because the mean median doesn't apply to non-numeric values. Okay, you cannot do mean median mode over here because you cannot do mean and median because these are non-numerical in nature. Now, same thing with most common complaints or response in surveys. So, for example, if you take a survey and ask which feature do you use the most, it could be search, chat, search, chat. So, in this case, you want to use the mode. Okay, most frequent value. Then another one would be discrete data. So let's say if a school checks exams marks on a scale of 1 to 10, and people's score scale, let's say their score is 8, 8, 9, 8, 7, 8, 9. In this case, you want to use the mode because that's the most students scored. In this case, you don't want to use the median mean. You want to use the mode in this case. Why? Because your most typical outcome in the discrete numeric data. In this case, it shows the most typical outcome in your discrete numerical data. I hope this session helps. Thank you, sir.